developer experience is important because it can be directly correlated to positive outcomes. We see increases in productivity, motivation, and quality, and of deliverables across the board when developers have positive experience.
We want developers to be developers, give them everything they need so that they can deliver the solutions quickly.
The most important aspects of DevX for me are self-service and skill reusability. We don't want engineers feeling like they're stuck learning technology that leaves them obsolete or not marketable in a few years.
I've been a developer all my life. If you tell me you have to use this one tool, I'll get very upset. I want to use any tool I want. And for us, it gives us the basic foundation of giving the developer the freedom.
We're improving deep DevX by constantly evaluating and measuring whether our engineers feel positive, secure, and motivated to work in our organization. I don't want them to feel that their job security relies on having a proprietary knowledge about a specific software and tool. I would like them to see my organization as a place where they can grow, learn, and enjoy problem solving that ultimately leads to end customer value.
Tanzu application platform has a number of features that we feel is going to be a game changer for us.
Both Spring and Tanzu products support all aspects of our DevX goals. We're utilizing industry-standard tools and methodologies that support developer ergonomics and put capabilities at their fingerprints that they never had before.
Hello, friends. Hello, friend.
Hey, friend.
I am so happy that we're together today. We're glad that you could make it. I'm Josh Long, Spring Developer Advocate on the Spring team at VMware.
And I'm Deshaun Carter, also a Spring Developer Advocate at VMware. Josh, I'm so jazzed that I get to present with you today. We've got so many great things to cover from the Spring and Cloud Native world. Before we get into it, some housekeeping. We have closed captions available if you'd like them. Just select them in the lower corner, right corner of your screen. And if you'd like to chat with our attendees, other attendees, and our team, please join our Discord. And if you're like me and on Twitter or Mastodon, use the hashtag SpringOne to join the conversation.
Well, 2022 was a big year for Spring. We delivered on years of effort to release Spring Framework 6 and Spring Boot 3, which integrate the latest and greatest in the Java language, new Jakarta EE support, a new unified observability abstraction supporting both tracing and metrics, and a new AOT engine supporting GraalVM native images.
It's been a great year for developer platforms as well. Kubernetes is powerful, but we all know can be a little tedious to deal with. So, over a year ago, we launched the Tanzu application platform to smooth that out. Spring is integrated right into it, so it's the easiest way to make cloud-native apps with Spring or whatever else you're coding in. You'll hear more about that today.
All of these center on one thing, getting you to my favorite place on the internet, production, even faster. Developers have to spend too much time on plumbing instead of the thrill of coding and deploying their applications to production. Spring has always been about developer productivity, getting that plumbing out of the way. And we're so lucky to be right in the middle of another evolution of developer productivity.
We're going to bring you up to the speed on all of this today. You'll hear about some exciting Spring projects and how the community is doing. You'll hear how one huge organization is using Spring in Azure to deliver our packages worldwide. And also all about the Tanzu developer platforms and internal developer portals that we've been building. And that's just day one. After our keynote today, we'll switch over to a single track series of breakout sessions today, tomorrow, and Thursday. And then after this week, we'll be sharing breakout sessions weekly with you. These will be live streamed on Tuesdays and Thursdays at noon Eastern on Tanzu.tv. Look out for an email from the SpringOne team with more details. But today, stay right here, right now, and you'll hear the keynotes with more tomorrow.
At VMware, we've been building the best cloud-native tools, practices, and platforms with our community for years. What we're doing with the Tanzu platform is driven by what we hear from you. And of course, you'll notice Spring's influence, like using inversion of control to deploy your applications to Kubernetes. Spring and Kubernetes are core to VMware's focus on modern applications. So, let's hear from the CEO of VMware, Raghu Raghuram, on VMware's mission and commitment to helping you build and run the best cloud-native applications everywhere.
Thank you, Josh and Deshaun, and hello, everyone. I want to take this opportunity to welcome you to the opening day of the SpringOne Essentials conference. It's great to have so many members from the Spring community joining us. This is a celebration of the innovation that you have all created and inspired. As you know, VMware is a fundamental part of how IT manages infrastructure. We got started by helping developers virtualize their desktops and making them so much more productive. At VMware, we believe developers are at the forefront of innovation. Today, we are continuing that focus on developers with the Spring Framework and VMware's Tanzu platform. Spring has always been about simplifying the app stack to let developers focus on coding. In the same spirit, the VMware Tanzu platform simplifies the experience of infrastructure like Kubernetes so that developers can continue to focus on coding. Infrastructure and operations teams are using Tanzu to build reliable, secure, and scalable platforms to create great experiences for you, the developer. I've talked with leaders at many organizations who are focused on the idea of platform engineering. And this is exactly what the Tanzu platform does. It gives organizations the tools needed to make developers more productive and happier. Today, you will see how that focus is paying off for developers, especially Spring developers. Building better collaboration between infrastructure and app dev teams means higher quality cloud-native software that runs more efficiently and more securely. Your work is incredibly important. Developers like you are using Spring and VMware Tanzu to build some of the most mission-critical applications in the world, running across multiple clouds and at the edge. The Spring Framework is a foundation for millions of applications that all of us use every day, and you are the ones that are making it happen. We are committed to building upon our rich history in app dev, enabling the next generation of cloud-native patterns and innovation in our multi-cloud world. We have exciting announcements to cover today for Spring and Tanzu. Here to share more about how Spring continues to shape the cloud-native developer experience is a longtime friend of the Spring community, James Waters. Thanks again for joining us today, and enjoy the conference.
Thanks, Raghu. Raghu is always pretty bold in challenging us all to remain cloud smart in our multi-cloud journey. And, I've observed that one of the urgent challenges of remaining cloud smart is balancing innovation, using any cloud service that you like, and standardization and the ability to drive consistency in day two operations for your organization and have a hireable skill set. Today, the range of open sourced and managed cloud middleware components, it's expanding every day, and it's currently beyond many applications teams' ability to integrate, conveniently and readily. Complex infrastructure configuration work can also distract development teams from really delivering business value, which is, why they get excited to go to work in the morning. Many organizations are beginning to standardize their cloud infrastructure. But doing that alone can leave costly gaps in developer experience and create a day two operating complexity. What happens on that application after it's deployed? A lot of things. So to improve standardization and move beyond the basic foundations of infrastructure as code, some leading organizations working on public cloud with innovative applications, they're now connecting their developer experience to a pre-curated set of ready-to-deploy application templates that work end-to-end. We're calling them golden paths as a community. Golden Paths deliver an organization's cloud app best practices from the very first line of code in an IDE on the developer's laptop, and then guide those development teams through a consistent and much more application-centric deployment process through all of CI/CD running in Kubernetes. By diffusing application deployment, operations, and best practices, attempting to do that is both a cultural and a technological challenge. It requires a shared platform team to enable these best practices across applications and an ongoing cultural focus on improving application architectures. People need to talk. A platform team's first job is to find and enable the most popular existing and target application architectures. A back-end Java application service is a very popular place to start on a golden path. With its continued growth and massive ecosystem, Spring Boot is often a platform team's first golden path. The Spring Boot community has continued to support the latest innovations, helping that balance between innovation and standardization by bringing new technologies like Kubernetes, API-first development, Kafka streaming, and the general move to microservices architectures to an existing developer skill set and community. And this unique balance and continued innovation has allowed Spring Boot to continue to grow over 50% every year for the last 5 years. And it positions Spring Boot as an ideal modern application standard, both for platform teams and development and architecture. Recognizing the almost gold standard nature of Spring Boot in the cloud ecosystem, Microsoft now supports it as a first-class service on Azure. Azure features this first-class Spring Boot deployment and operation service, Azure Spring Apps Enterprise. And it dramatically reduces the complexity of building a Spring Boot golden path on Azure. And I think, if you think about it, it's really indicative of this broader industry move that will continue over the next 5 years to further abstract development teams from complex infrastructure configuration work and toil. And as the primary contributor to the Spring Boot community, the Tanzu team is also investing to reduce the ability of building golden paths for Spring or any application on the Kubernetes of your choice. The Tanzu application platform now allows you to bring this golden path level of deployment to any Kubernetes on any cloud, and you're going to hear a lot more about that and many other exciting developments in the Spring community today. I can't wait.
Thanks, James. This culture of golden paths that James shared with us is heavily influenced by the Spring community. The work we've done to make cloud-native development easier and more fun has been an inspiration. I'm so excited to introduce the next speaker who will tell you all about the state of our community and the community's accomplishments. Spring co-founder, Spring Framework project lead, the reason for the season, my hero and friend, Jürgen Haller.
Welcome. It is my pleasure to introduce Spring Framework 6 as a new generation of Spring for 2023 and beyond. Spring Framework 6.0 and Spring Boot 3.0 are available right now. However, they are only really the start of a new generation of the framework for many years to come. As with every major revision of the framework, we take the opportunity to revisit our baseline. And our new baseline is JDK 17+. A minimum of Java 17 at compile time as well as runtime. And Jakarta EE 9+, the Java EE APIs in a new namespace. JDK 17 is the current long-term support release of Java. That said, there's already a next long-term support release of Java on the horizon, JDK 21, coming up in September 2023. So in the very near future, there will be 2 LTS releases of Java to choose from for your Spring Framework 6 and Spring Boot 3 based applications already. Jakarta EE 9 brings a namespace change to the Jakarta namespace. So, for example, in the Servlet API, what used to be javax.servlet is now jakarta.servlet. In JPA, what used to be javax.persistence is now jakarta.persistence. This is quite a disruptive step to take for the ecosystem. Not only your application code needs to be adapted, if you're referring to annotation types or API types from those packages, it's also the libraries and the frameworks that provide us interacting with those APIs. They all need to provide versions supporting the Jakarta equivalents. Jakarta EE9, as an initial release, is just a repackaging of Java EE8 into the new namespace. There's a feature release available in this new generation already, Jakarta EE10, with actual new features in the Servlet API and in JPA, for example. And EE10 is well supported in the ecosystem already, well adopted. There are providers such as Tomcat 10.1, Hibernate ORM 6.1. So there's a wide Jakarta EE10 baseline established for the current generation of the infrastructure that we're using in the Java ecosystem. We strongly recommend an early upgrade to Java 17, to the Jakarta namespace EE APIs, to Spring Framework 6.0, to Spring Boot 3.0, all going together very nicely. Fortunately, 60% of the respondents to our recent State of Spring survey indicated that they have Spring Boot 2.7 in production in some form already, which is a great starting point for the upgrade. 70% of the respondents indicated that they plan to upgrade to our new baseline in the course of 2023, which is great to hear because it puts ourselves and yourselves into a position where we are ready to embrace further innovation from here in the Spring Framework 6.x feature releases, in the even more frequent Spring Boot 3.x feature releases, in new releases of the JDK that we can run on, of course also in new providers and libraries emerging in the ecosystem. Let's move on to AOT and native. Let's take an application deployment perspective. There are two key concerns for modern-day cloud deployment: startup time and the memory footprint. A major infrastructure theme that is with us for this entire generation of the framework is AOT processing, moving certain processing steps to the build time and producing a more optimal representation of your application for deployment purposes. AOT stands for ahead of time. What we mean with Spring AOT is our supporting infrastructure for the Spring Core container, where we take an existing application context setup, application context configuration, and we're turning it into a tighter representation, reducing the amount of reflection, producing runtime hints for any remaining reflection, for resources that need to be present at runtime. The outcome of such an AOT build time step can be used for optimizing deployment arrangements on the hotspot JVM, but in particular also as a mandatory step to take for GraalVM native images. So an AOT processed Spring application, we can feed it into the GraalVM native image compiler in order to arrive at a native executable that can run a specific version of your application, a specific variant of your application on a specific target architecture in the best possible, in the most efficient form possible. Almost 50% of the respondents to our survey indicated that they plan to adopt GraalVM going forward. So this topic is very much with us for the next few years. A related OpenJDK initiative is Project Leiden. Leiden is essentially a standardization effort for variants of static images, a spectrum where GraalVM native images represent the one end of this spectrum with a strong closed world constraint and very significant benefits attached. Other options may emerge with weaker constraints and still significant benefits attached. So Project Leiden has not actually delivered concrete results yet. It's an ongoing project, an ongoing effort that we're closely tracking, that we're pre-aligning with for our own Spring AOT strategy. Another related OpenJDK project coming from a quite different technical angle is Project Crack. Crack stands for Coordinated Restore at Checkpoint. It's essentially about taking a Spring application on a hotspot JVM, bootstrapping it, warming it up with some initial requests, then taking a snapshot, and for further deployment purposes, for further bootstrapping attempts, start from that snapshot, restoring that snapshot, taking it from there. Project Crack is developed by Azure. The approach is also adopted in AWS Lambda Snapstart. This can dramatically improve startup time, but otherwise you're running your application on a regular hotspot JVM. So no other constraints attached, also no other benefits attached, focusing on the startup time problem only. Let's move on to virtual threads. We are essentially revisiting Java threading from the perspective of scalability, from the perspective of the footprint of each individual thread. Virtual threads are being introduced by OpenJDK's Project Loon as a lightweight thread representation within the JVM, managed by the JVM, decoupling it from the notion of an operating system thread. A virtual thread, for actual processing purposes, is always attached to an actual platform thread, to an actual operating system thread. However, whenever a virtual thread reaches a blocking point, a blocking API call, I/O operations, networking operations, blocking data store calls, it implicitly gets detached from its carrier thread, releasing the original operating system thread for other processing tasks. Whenever the data arrives, whenever the call returns, the virtual thread gets reattached to a platform thread and continues processing from there. This kind of scenario is very common in servlet applications, in servlet processing callbacks, in JPA and JDBC interactions, in Spring MVC on a servlet container performing JDBC or JPA interactions. Virtual threads can be a very useful tool in the toolbox for reaching a different level of scalability with rather traditional thread-bound imperative programming models. Virtual threads are currently in preview in JDK 19. They are going to enter second preview in JDK 20, and let's see where they land in JDK 21. We are eagerly awaiting their non-preview arrival, and so are you. More than a third of the respondents to our State of Spring survey indicated that they plan to adopt virtual threads whenever they become available. And virtual threads are also one of the topics where I provided a deeper dive in my infrastructure themes breakout session. In Spring Framework 6.0, we also took the opportunity to revisit some web framework fundamentals. Just a few highlights. We introduced the notion of HTTP interface clients, essentially annotated methods in a Java interface initiating an HTTP client interaction. There's a dedicated breakout session on that topic. We support RFC 7827 problem details as a standard HTTP error response with a rich structure. And as a strategic initiative, we embrace micrometer-based observability across the stack, not only for the server processing part of it, but also, for example, for HTTP client interactions through the framework. There's a dedicated breakout on observability as well. What's next? We're currently working on the Spring Framework 6 OX line, with Spring Boot 3.1 to be released on top of it in the second quarter of 2023. Our next core framework feature release will be Spring Framework 6.1, with Spring Boot 3.2 on top of it to be released in the fourth quarter of 2023. Then already in a state of the Java ecosystem where JDK 21 will be available as the next long-term support release of Java, and where several initiatives that we're tracking have made some progress already. Here is the State of Spring survey, which I've been quoting from. And last but not least, we are also introducing Spring Academy, which brings the latest in Spring education to application developers, with a curriculum curated by the team behind Spring. With free membership and a paid subscription tier, you can choose the educational option that best meets your needs. So that's my wrap-up for today. If you'd like to dive deeper on some of the topics that I've mentioned, please join me for my Spring Framework 6 Infrastructure Themes session.
One of the biggest things the community worked on this year is native Java support for Spring Boot. Running native Java gives us huge performance improvements. It can make some of our applications run better, especially in cloud-native architectures. Next, let's hear all about this from Sebastian Deleuze and Thomas Werthinger.
Hey, I'm Sebastian Deleuze. I'm a Spring Framework committer, and I'm also the co-founder of the Spring Native Experimental Project, and I'm welcoming Thomas.
Hi, Sebastian. I'm Thomas. I'm the GraalVM founder and project lead. And today we're going to talk about GraalVM and Spring. Sebastian, why would I care about deploying a Spring app with GraalVM?
Yeah, so we are really going to talk about reducing the costs and making more efficient to deploy Spring application to the cloud. And that's how GraalVM can be used. I'm pleased to announce today that Spring Boot 3 introduces official support for compiling application to native executable thanks to GraalVM. And that has been done through a very nice collaboration with the GraalVM teams.
Yeah, this has been an excellent engineering collaboration between the GraalVM team and the Spring team. We've worked very hard together to make sure that Spring applications work well with GraalVM and work well with GraalVM native image. And it's really great to see that frameworks like Spring have support now for that GraalVM technologies. We also recently have announced the collaboration on having libraries in the ecosystem, like third-party libraries that are provided with metadata, and to have those libraries metadata on our website to make sure that people can use those libraries.
Yeah, this has been really a win-win collaboration because Spring team has worked with your team to make it sure that Spring itself works great when it is compiled to GraalVM native images. But we have also collaborated with you in order to have support for libraries on native, and this support can be used by any frameworks. So we really try to make the GVM ecosystem native friendly and collaborate with the wider GVM ecosystem on that.
Yeah, that's really cool. And so when I currently have a Spring application, when I just deploy it in GVM mode, how do I do that?
Yeah, so typical deployment of a Spring Boot application is you have your application, you compile it with Maven or Gradle using Java-C underneath. You have the bytecode, you package it as a container. So typically your container will contain an operating system, the Java virtual machine, and your application and libraries. And you ship that on production in the cloud, on your Kubernetes cluster, etc.
And so now with native image, how does that change?
Yeah, so to be clear, you keep being able to deploy your Spring Boot application with the GVM, like I shared just before, but we are adding a new capability, which is basically you have your application, you are compiling it, but we are adding some ahead of time optimization and transformation that make your Spring application more efficient, more compatible with the GraalVM native image compiler. And basically, the Java bytecode is then compiled to a native executable by the native image compiler that is provided by the GraalVM team. And the outcome is still a container image, but it is a smaller one, a more optimized one that is based on a minimal operating system and just the native executable, no GVM, no bytecode chip. It's really just the minimal operating system and the executable code.
Right. Yeah. And I mean, there's many benefits why one would want to run as a native image. The first and most obvious one, of course, is the instant startup. Yeah. Like the application is there immediately. There's no delay to serve the first request. But it's also the warm-up phase. So for the first several thousands of requests, you're faster because you don't need to warm up your application first. And the performance is even more predictable because you know what the ahead-of-time compiler produced. So the performance really is the same between runs. Finally, also, research usage is lower, meaning if you run here with a native image, typically you can run in a smaller cloud instance, or you can run with less memory assigned to your application, which makes your application then cheaper to operate. And from a security perspective, there is another aspect where native image can provide benefits in terms of reducing the attack surface, because when you deploy the app, you reduce certain vectors like arbitrary reflection or calling parts of the application that you did never intend to be called. And this can help with improving the security profile of your application. Finally, as you mentioned in previously, it's also compact packaging because you can run in Docker, you can run on a minimal operating system, and you can deploy your app on a smaller Docker image, typically compared when you have a GVM-based deployment. So, but I mean, native image, it's not like a silver bullet, meaning there are also some downsides to it. And I think the Spring team has made some analysis also in which scenarios would they recommend native image versus in which scenarios would they say, well, for now, at least keep running in the GVM mode. And what are those scenarios?
Yeah, exactly. So developers usually ask, in what case should I use GVM? In which case should I use native? And it really depends because that's different trade-off. So the use case where we typically recommend using native is when you want to run your application on a very cheap cloud instance, typically 1 vCPU, 1 gigabyte of memory. You want to lower and optimize the cost of operating your application. Typically for that, using native is a good fit. If you want to deploy your Spring workloads to a function as a service or in a scale to zero fashion. So by scale to zero, I mean you deploy your Spring application on a container that can scale to zero. I mean consume no resources when the application does not receive any request. And when some requests are coming, it basically scale up and serve the application. So it's a good way to optimize the cost, and native with instant startup capacity is a very good fit for that. Other use cases where you need to assess if native is a good fit or not compared to the GVM, if you have multiple microservices, if you are deploying back offices not used all the time, if you are deploying to Kubernetes cluster, or if you deploy your product as a container image, you should typically assess if native is a good fit. And lastly, currently there is some use case where the GVM is likely better. So a typical drawback of native is the very long build time. So if you are building your application multiple times a day, maybe the native build will be a drawback. If you want to deploy a very high traffic website, if you are not limited in terms of resources, but you can deploy on a very big server with a lot of memory, a lot of CPU, or if you have a big monolithic application, then maybe the GVM is better. But I think the boundaries are moving, and maybe you can share more about the upcoming evolution of GraalVM.
Yeah, and I think this is a very good assessment of the current situation, but the GraalVM team is actually working very hard to make sure that the boundaries are moving here in the sense that there will be in the future even more scenarios where native is better.
Okay.
We're working on improving the peak performance and the throughput as well. But I think for now, this is a very good assessment of the different trade-offs and when you should currently with the Spring application use native versus when you use JVM. And so, Sebastian, let's say I have now a Spring application, a Spring Boot application on version 2, and Spring Boot 3 was now released, and I'm excited to get my application now to run on native image. Like, what are the steps?
Yeah, I think that's a super interesting use case because we are not talking about introducing native support for a new application. We are also talking about enabling developers to migrate their existing Spring Boot 2 application on the GVM to be able to deploy to native. And the goal of what we did is we don't require you to change your application much. It's really about first migrating to Java 17. So we advise people to keep their Spring Boot 2 application and just change the Java version and use Java 17 because this is the minimal version supported in Spring Boot 3 and Spring Framework 6. Then, as a second step, you can upgrade to Spring Boot 3 and use this opportunity to migrate from Java EE to Jakarta EE. So that's the second step. And we have worked a lot in the Spring Boot team to make sure that the upgrade experience from Spring Boot 2 to Spring Boot 3 is reasonable and efficient. The third step is ensuring native compatibility. That means that you should check that your libraries typically are supported on native using the GraalVM reachability metadata repository, for example. You may need to add some hints. Native requires some explicit configuration for reflection, for resources, for proxies. Spring tries to infer most of those, but there is maybe some corner case where we are not able to infer that, and so you need to explicitly configure those hints. Mm-hmm. Then you should be able to build a native executable based on your Spring Boot application. And the last step is just to deploy it as a native container, and you can go on production with that.
Cool, sounds great.
Another important thing is that our customers has really asked end-to-end support for native, and so I'm also pleased to announce that VMware Spring Runtime provide end-to-end support for native. From the GraalVM native image distribution, we are leveraging Liberica native image kit for that. And we also provide support for Spring itself, obviously, because we are basically providing any kind of fixes and improvement to make sure that your Spring application runs fine on native. But I have heard something about GraalVM and OpenJDK. Could you share more about that, Thomas?
Yeah, absolutely. So we recently announced at Java 1 that the Java-related parts of GraalVM will be contributed to the OpenJDK open source project, and we are super excited about that. This will help us further align GraalVM to the Java community and to the OpenJDK project specifically. We are looking forward to work there with the community of OpenJDK to make sure GraalVM can be used by as many Java developers as possible. And now I think, Sebastian, I think you've not only prepared here some slides, you also have prepared some demos that you will do now together with Sandro, and I'm looking forward to watch them now.
Thanks, Thomas.
Thank you.
Okay, so it's demo time. Welcome, Sandra.
Hey, Sebastian. My name is Sandra Agrim, and I'm a cloud developer advocate working at Microsoft for Java developers. It's great to be here. What are we going to do now?
Yeah, so we are going to deploy some Spring Boot native application in the cloud and more specifically on Azure. So we are going to deploy a version of Pet Clinic that has been migrated to Spring Boot 3 as a native application in the cloud on a low resources instances. And we are going to modify a little bit our regular Pet Clinic in order to have some image analysis capability using Azure Computer Vision. We are going also to store the images on Azure Storage, and we are going to deploy that as a scale to 0 instance on Azure Spring application. So let's start the demos.
Yeah, sure. So I'm very happy to being able to showcase the native compilation on Azure Spring Apps Enterprise, as well as the scale to 0 capability, and also our Spring Boot 3 support now in Spring Cloud Azure. So let's just go ahead and create a new Azure Spring Apps Enterprise cluster. So I search for Spring Apps and select the Azure Spring Apps Enterprise. And then I just click on subscribe, create a new resource group. So I have everything bound together that needs to be together for this demo we just explained. I will just give it a name, select the region, one of the closest, so West Europe it is, or even East US. I select the perfect pricing tier for me. Here it's Enterprise because we want to show something production ready. I give some good numbers of allocated resources because I also want to compile and build my native application in the cloud, not on my machine. I disable some capabilities because we don't need to show everything here. And I will also enable the developer tooling to make sure that I can use the application live view also. So now the deployment is in progress. You can see here everything is getting created. Also the monitoring systems are instantiated for me, or for us. And now I can go ahead and create a native build service because it already comes with the default build service. But as we also want to build and deploy native applications, I want to create a new one, give it a name like native, select the Bionic base, and add here the Java native image build pack.
Okay, so this is going to allow you to build the native application in the cloud directly on the build service that is on Azure, right?
Exactly. So I'm independent on my compute. I have locally here. I'm also independent on the US. I have locally. So that's actually pretty cool. Mm-hmm. So let's go ahead and deploy the famous Pet Clinic application. We've already transformed that to Spring 3 with the Spring Boot 3 with the Java 17 version. So just make sure to have the correct properties set. I just did that here I'm just doing it here in my Cloud Shell. And I make sure I have Java 17 installed. And then I can just compile my application in the cloud and also package it and then deploy the app to my Azure Spring Apps Enterprise cluster. So even if my local compute isn't as good or not that performant, I can just use a heavy machine in the cloud, which is pretty cool. So I'm assigning an endpoint, and here we go with the famous pet clinic application you're all aware of. So let's now jump ahead and go from 0 to hero with the image service.
Yeah, so now that we have migrated an existing application to a native, we are going to build a new one from scratch. So we are going to leverage start.spring.io and more specifically the integration into my IDE, so IntelliJ IDE in that case. I'm selecting the GraalVM native support that is available as of Spring Boot 3. I'm going to create a regular Spring Web Flux application. So this is a typical programming model that you already know. I'm adding the Azure Storage support because we are going to use the Azure Java SDK to request and use Azure Storage. So I'm going to add a configuration property that is required in my application to configure how we are going to reach the Azure Computer Vision thing. I'm enabling this configuration property with this @enable configuration properties annotation. And then I'm creating a new controller. So this is a Spring Web Flux controller. Again, a regular one, nothing special. I'm going to create this controller. You see that we have a few record classes because we are using Java 17 to deal with the data classes, etc. And we are going to configure it with various properties, initialize the asynchronous Azure Storage client. And you see here the post mapping endpoint. This is what is going to take as an input the bytes of the image. There is a file name parameter, and then what we return is the image that has been analyzed and various metadata that we are going to show. The only specific bits for the native support, because this is a regular GVM application, we are adding this @register reflection for binding thing in order to basically configure explicitly that we need to have reflection available on vision request body, vision response body. This is the only code that is specific to native. Otherwise, this is just a regular Spring Boot application. I'm just going also to add a little bit of configuration because we are using Azure SDK that is using SignJar, and that's why we need this additional configuration. But that's all. And here, I'm running locally on my laptop this time the native compilation. So this is using buildpack in order to create a minimal container image. We have fast forward because in reality that takes 3 minutes. I'm starting locally this Docker image and I'm going to test it. Basically, we are going to send an HTTP request, providing in the request body the content of the image that will be analyzed by Azure Computer Vision. And you are going to see that it returns a few tags that identify that's an animal, that's a cat, etc. And we have the URL of the image that have been uploaded and stored in Azure Storage. And the Azure Storage blob endpoint will just serve this image without having to have my scale to 0 image service available. And yeah, that seems to work pretty well. So the next part is that we are going to so we are going to see the various image containers that are possible. We can create a GVM one that will be close to 300 megabytes. We can create the native one, which is much smaller, 125 megabytes. And then we can also create a native one that is compressed with UPX. It's only 50 megabytes, so pretty small. We are now uploading the container that we have been created locally in a remote private container registry that is on Azure in order to make this available for our application. And we are deploying and creating a Spring application using Azure Spring Apps. That is using the container image as an input. And then we configure this application to scale from 0 to 2. That means that when my application is not used, it will just shut down. I don't pay anything. And if there is more requests, basically the application will scale up.
Cool. So let's see how that looks all together, right? So the pet clinic application with the native compiled image service. So I can go here into my pet clinic application. I find a new owner, or find an owner, Maria. She also had a cat, so I will add Bonnie here. Give it a name, select the birth date. I don't select the type, and here I select an image. Oh, did I misclick? I think so. Oh yeah, that is the handy error for me. So I see that I actually misclicked. So I go back and select the correct image. There we go, here it is, the Bonnie cat, and it also found out that it is a cat actually.
So the type has been auto-detected by Azure Computer Vision, right?
Yes.
Okay.
So let's see how that looks like in the application live view. So here I can select my HTTP exchange. I can already see some graphs, even though I'm using now the native image service. So which is pretty cool. And to make that a bit more impressive, I'm now running some scripts to generate more load for it. So here you can actually also enable the actuator, so you also have some client errors, which makes it even more impressive.
It's pretty cool to be able to see the traces even on a native app, so you can have some kind of observability. That's
yeah, you might guess that you don't have any metrics, but you do have. So let's compare also how fast the image service was scaling from 0 to 1. So here I can see for the native one, it was in 179 milliseconds. And for the one in JVM, you also uploaded this one. This one was a bit slower, so let's see. Here we go. So 14 seconds. So wow, that's quite impressive.
That's a big difference, yeah.
Yeah, and with the milliseconds, you won't even notice this as a user. So that's really cool. So let's see the replica count. You saw I also did some load. I generated some load to see if it would scale up even more. And there you go. So you see I also scaled it up to 2 services, instances, and then again to 0 to have no cost at all. When we didn't use the image service, we make sure that the images were still there, persistent in the Azure Blob storage, but everything else can just scale down to 0.
Amazing demo. Thanks, Sandra.
Thanks.
Like you just saw, Spring can run pretty much anywhere. You just saw Sebastian create a native Java application in Spring Boot and run it in Azure. This is a great example of putting a golden path in place to max out developer productivity. And it's also a great example of why Spring is one of the best ways to create cloud-native apps. You can run Spring apps on all sorts of clouds. Next, let's continue our exploration of Azure Spring apps with Amanda Silver and Ryan Morgan.
We just got a glimpse into the streamlined developer experience that's made possible when building and deploying apps with Spring and Azure Spring Apps Enterprise. Earlier in the program, James Waters talked about the power of golden paths, a curated set of components and activities that help development teams build and deploy applications without having to spend time thinking about the automation and tooling related to their infrastructure. Both VMware and Microsoft focus their efforts on improving the developer experience, and I'm joined by Amanda Silver from Microsoft to talk about how Azure Spring Apps Enterprise enables golden paths for developers.
Thanks, Ryan. You know, as head of product for Microsoft's developer division, I also manage the engineering systems that Microsoft's internal developers use. So the idea of a golden path to production is very important to me. I've spent my career advocating for developers, and there are lots of challenges they face in the current environment. Managing infrastructure and app lifecycle, troubleshooting, maintaining security, and collaborating across remote teams. Microsoft is committed to offering Java developers an end-to-end cloud experience for all of their apps, including Spring. With Azure Spring Apps Enterprise, developers can build and scale distributed workloads, externalize configuration, enable service registration and discovery, secure apps, and monitor end-to-end. They can also easily integrate with other Azure services and use developer tools like GitHub and Visual Studio Code.
Let's go through some of the new capabilities we've recently announced for Azure Spring Apps Enterprise.
You know, there's a few things to highlight. First, we now have Application Accelerator in Enterprise. It's a new code templating feature that helps developers get started quickly and brings consistency for dev teams and architects. We've also added Application Live View, which helps developers troubleshoot issues at the application layer with app-centric tooling. And to improve resource utilization, we've introduced a new pricing plan with scale to zero and event-driven scale up and scale down capabilities. Now, combining these new serverless features with Spring Boot 3's ability to run applications that are natively compiled, and you can run the same Spring workloads with even less compute resources and quicker startup times.
Yes, we're really excited to bring these new VMware Tanzu capabilities to Azure Spring Apps. And because these developer experience features are shared across both Azure Spring Apps Enterprise and Tanzu Application Platform, enterprise developers will have a consistent experience across their cloud environments.
You know, you can think of Azure Spring Apps as a golden path to get your Spring apps into production in the cloud. We're really excited to see what you're going to build, and you can get started today.
Thank you so much, Amanda, and thank you for joining us today.
With Azure Spring Apps, getting your Spring apps up and running is so easy, whether it's just you, a small startup team, or a giant company like FedEx. You should do it today. Do it now. Do it this evening. Your children can do it. Your cats could do it. Even your leftover kale salad could deploy native Java applications. Now, let's take a look at one of the big achievements of the year, harnessing the awesome momentum of the Spring community to deliver the Spring Authorization Server. Grab some popcorn as we get the story from Steve Reisenberg and Joe Granja.
Hey, Joe.
Hey, Steve, how's it going?
It's going well. What's up, man?
I got amazing news. We've been given the go-ahead to build our own authorization server product in-house.
Awesome. That is great news.
Exciting.
You know, business demand is up. I think bringing development of the authorization server in-house is really going to save on cost. So we use a lot of open source here. I wonder, have you been able to narrow it down to an open source solution we can build on?
As a matter of fact, I have. We're using Spring extensively in-house, right? So it's a natural fit to use Spring Authorization Server. It's not a product, though, like a current solution, right? It's a framework, but ultimately we could build the product on top of Spring Authorization Server.
Interesting. So since it's a framework, it must be quite flexible. I wonder what other benefits can it provide for us?
Well, the biggest benefit, it's built on top of Spring Security. Right? So automatically we're inheriting the secure defaults, all the features that come with Spring Security. It allows us to integrate with any authentication system. So any of our user database across all our environments supports Active Directory, LDAP, SAML, any authentication system. So high flexibility. And we could use it for our single sign-on needs too.
Interesting. Now we have a pretty complex environment internally as well. So I wonder what other usage scenarios could Spring Authorization Server support for us?
Well, we're using Spring to build our microservices, right? We got to secure the interaction between the microservices. So we could use Spring Authorization Server to use OAuth 2 to secure between our microservices. That's not something we're doing today.
That sounds helpful, Joe. What about the development experience though? I'm wondering, is it easy to get started?
Well, I'm going to let you decide that. I actually tried it myself last week, but I'm going to walk you through it right now as an exercise.
Okay.
So let's pull up the project page. Okay, let's click on through the getting started.
Okay. Yeah, it says here that we can head over to Spring Initializer and generate a Spring Boot application to get started.
Okay, let's do that.
Great.
Now the first things we got to do is we got to add our dependencies. So we'll add Spring Web, Spring Security.
Okay. Anything else?
That's all we got to do. So let's generate that, download it, and then open it up in our IDE.
Okay. Let me just launch this here. And then I'll open up the build Gradle.
Okay, and then the next thing, just with any Spring Boot project, we got to add our dependencies. So go back to the Getting Started guide. We'll grab the Spring Authorization Server 1.0 dependency.
Okay. So I'll just add that and re-import here.
And the only other thing that I did when I tried this last week is if we move down a little bit here, there's a bunch of code. Copy all that code.
Okay.
And we'll just paste it into the Spring Boot application. And then we'll do a high-level overview of the components.
Okay. Let me just add this to the project here. There we go.
Okay, so here we have it, right? So the authorization service security filter chain. So essentially what is happening here, as per the applied default security, it's setting up the default protocol endpoints, right? We just got to add one customization because we're gonna test out the OpenID Connect flow. So as you can see here, in the sample, it's enabling OpenID Connect.
Okay.
Then we got the default security filter chain, right? So this is the Spring security filter chain, right? This is where we're going to set up our authentication subsystem. We're just going to use form login. This is a basic sample. We just want to test it out. We're going to have one user. That's the user detail service. Now this next component, this is the central component for Spring Authorization Server, the registered client repository. This is the repository where all our registered clients, right, and associated metadata are.
Okay.
As you can see there, the OpenID Connect scope, right? We need that enabled or configured for this client.
Okay.
Because we're going to test that flow out. Are there any other changes we should make here?
Yeah, I'm just going to change this to test client here for the client ID, so that matches our development environment.
Okay.
And then I'm going to go ahead and add port 9000 to this. And that just enables us to use the same port that we're using in development as well. And while we're at it, let's go ahead and add trace logging with Spring Security as well.
Perfect.
With that, I think we can launch this application and authorize a client.
We're ready to go. Let's try this out.
Okay. So I happen to have a client running on port 8080, so I'm going to go ahead and go to my browser and launch that right now. And I expect it to redirect to the login page of Spring Authorization Server if this is working correctly.
Okay, there we have it.
There we go. So with that, I can just log in with the sample user and password that we set up.
Okay.
And then it looks like it's taking us to a consent page.
Screen. Okay, yep.
Yeah, so it says test client, so that tells me that our configuration is working and it knows what user I'm logged in with, and it's asking me for consent to access my profile, which tells me it's using OpenID Connect.
That standard scope profile, yep. Let's give it the consent.
Okay, so I'm going to go ahead and submit this, and it took us right back to the client. I mean,
there we have it.
We're logged in.
So what do you think now?
That was pretty easy, Joe.
I think so too. That's what I thought. Developer experience is obviously pretty smooth at this point, but the most critical piece of information that we got to discover and find out is production, right? If we're going to take this to production, right, what are the questions we need to answer?
Sure. Well, let's start with our public-facing website first.
Okay.
Now, we use social login to allow our customers to log in using an existing account.
Yes.
Like a social network or something like that. Does Spring Authorization Server support anything like this?
Well, it's not built into the framework, right? This is a product feature, right? But there is an official sample. Let's go to the official sample.
Okay.
I checked out this sample as well last week. Now, this sample here, it's a federated identity sample. It allows you to use your Google and GitHub credentials, your existing credentials to log in. So we could easily build social provider adapters within our product following this sample. So we got a great starting point.
Great. Now, most authorization server products come out of the box with some kind of admin UI.
Yes.
Would we need to build our own in this case?
Well, that's also a product feature, right? Spring Authorization Server is a framework, and we definitely got to build it. Like, we need to be able to administer clients and existing authorizations. There's use cases where we're going to want to, disable a client or revoke an access token if any of those credentials get leaked. So we definitely got to build these UIs. But the beautiful thing about this is we got the total flexibility to build a very simple UI that's easy for our users to use. Total control is within us.
Great. Yeah. So another thing is, if we're going to build this as a product internally, we're going to need some kind of commercial support, right?
Yes. So perfect timing. Spring Authorization Server went 1.0 recently. Because of this, it falls under the VMware Tanzu OS of Supports policy. We'll pull that up there.
Great. Okay.
All the details are here, so we should definitely review this with management. But better yet, commercial support. This is what we need to get. VMware Spring Runtime. Let's pull that up.
Okay.
And we'll review this. So as you can see, the support is available.
Nice. Wow, that's amazing. From everything I'm hearing, it seems like Spring Authorization Server is absolutely perfect for us. We have a team of developers that's ready to move on to their next project. How can we get them ramped up on this?
Well, perfect timing. There's a SpringOne Essentials coming up. We should definitely check it out. It's a deep dive talking about the configuration model, the extension points. We got to tap into this to build our features on top of the product.
Awesome. You know what? I have a great idea.
What's that?
We should talk to the team right now.
Let's do it.
You've heard a lot about developer productivity and developer experience. These are super important. If you're lucky, you've got a developer experience team that's taking care of your tools. And if you're even luckier, you've got a platform engineering team that's building and running your cloud-native platform and the golden path to production. Well, at VMware, we've been working on developer experience for over 10 years with open source projects like Cloud Foundry. And now we're doing it again for Kubernetes with the Tanzu application platform. Next up, Catherine McGarvey is going to tell you how Tanzu application platform is making developers' lives easier.
Hello. I love how the Spring community is making it even easier for devs to build cloud-native applications. As you heard from James Waters earlier, both frameworks and platforms are important to a company's ability to offer developers a golden path. These golden or paved paths to production are becoming more common in large IT orgs, offering an elegant solution to streamline the path to production for developers. These golden paths are key to enabling a great developer experience. Here at VMware Tanzu, we are obsessed with improving the developer experience. A great developer experience turns up productivity. It allows you to get started coding quickly without context switching. It makes it easy to find and leverage existing patterns and services. It supports better collaboration with other teams without long wait times or extra meetings. It makes it simple to get to production. We help developers to be more productive with solutions that create collaboration across functions, reduce toil, and promote a state of flow so that developers can focus on delivering value and meaningful outcomes. We've spent years working with customers to understand what's getting in the way of developer productivity and what challenges development teams face day to day that adds friction to their workflow and takes the focus away from iterating code due to having to work on process or other tasks. To streamline requirements, many companies have opted to switch to a ticketing system. Here are some real examples I've encountered learning about a customer's path to production and sitting with teams of engineers. So let's talk about the tickets. As an app dev team, if you're just getting started, you probably need to create a ticket to get an environment. You might need to specify the CPU, memory, translate app requirements into infrastructure concerns. Latency, expected traffic, performance testing. You typically have to do this early so that ticket can be served in time for your app to be able to utilize it. When you're ready to deploy your app, you probably need a ticket for approval. You might need an architecture review or something else to confirm you've met your company standards. To add a new team member, that's a ticket for onboarding to make sure they have access to the things they need. To learn about other services your company has, that's a ticket for discovery, to learn if something that you need might already exist. And then when you find the thing you might want to use, that's a ticket for permission and get access to that existing API. When you're ready to go to prod, there's a whole bunch of other tickets. Maybe you need to ensure that your staging environment matches your production environment. Things like mutual TLS and seeing how that has an impact on performance in that environment, that's a ticket. Perhaps you need to get that latest data service or middleware library, get the benefit of something new that's come out with the Spring community, and you want to be on the edge, that's a ticket. If there's compliance and other requirements that occur to make sure that what you're releasing is secure, that's another ticket. If you have app-specific needs, like you want to deploy Spring Cloud services to your runtime, you want to open a port, you want to have a sidecar, you want to have anything else related to your app, that's probably another ticket. That's a lot of tickets. Let me remind you of the outcomes that will serve developer productivity. One is no more tickets. The second is no more YAML. Now, we haven't spoken a lot about YAML, but I tell you, if I discover at LinkedIn that there's a badge to certify YAML developers or YAML editors, it'll just be plain sad. We want to say no to YAML. We want to say no to tickets. And what helps us reduce or move away from tickets? This golden path we spoke about, it's an improved architecture, approved platform services, a secure runtime environment that simplifies what it takes to get you to prod. I'm thrilled to announce Tanzu Application Platform 1.4, which allows you to easily collaborate, have a golden path, and say no to tickets. It does that through things like IDE integrations, live debug, trace, pause, seamless reload, architecture patterns that provide you libraries, integration, and choices that don't require approvals or feedback. Know that you're starting from the recommended set of choices. Published APIs that you can test against and consume. Use those existing services, discover what exists, but don't reinvent the wheel. Service is defined by how they support the app, not the infrastructure. High availability, size, sessions. Understanding the health of your app, troubleshooting it, logging insights into your app, you can know and plan for outcomes. All of this complemented by security. Layers below your application are patched, maintained, and tweaked for you. You're starting with a secure base image, an automated bill of materials, and an audit-ready output. Scanning and CVE management happens early. It gets put into your backlog each week, so you're not surprised at the end and there's not this mountain of things to address when your features are finished. Secure runtime for each environment, starting with secure by default. Integrations with Tanzu Service Mesh that allow developers to secure apps running in a cluster that has walls. Restricted capability tailored to your app needs. Priority, fairness, scheduling without noisy neighbor. Runtime optimized and tuned for your app. Your function, your data stream, your event-driven design, your workload. Expanding the data ecosystem. Today, we are delighted to announce the beta release of RabbitMQ as a service. With the managed service offering of RabbitMQ, developers and businesses will have the simplest way to use RabbitMQ for messaging and streaming. Increase the resiliency of your app without worrying about the infrastructure, deployment, or scaling of RabbitMQ. It's supported and backed by VMware. Our experts have been developing RabbitMQ, providing support, training, and professional services for it since 2010. We are jazzed to announce the beta release of Gemfire 10. This major new version brings features and enhancements that enable you to build high-performance, scalable applications more easily. A new management interface allows developers and operators to configure and manage a fleet of Gemfire clusters. Gemfire Search enables you to build full-text search capabilities into your apps that run at the speed of memory with the reliability of Gemfire. Included in it is Java 17 support and Spring for Gemfire compatibility. The introduction of pluggable modules so you can package and deploy server-side code independently without conflicting with existing Gemfire libraries. And that's huge. And expanding the app ecosystem even further with VMware Application Catalog. Developers can utilize a wealth of data services, app components, and runtimes through a curated self-service catalog. With all this, you may still have to check the box, but you don't need to have the meeting. We're with you on the evolution, the streamlined path to prod with Tanzu. Our Cloud Foundry and Tanzu Application Service community continues to inspire our journey to enabling ticketless, productive developers. Tanzu Application Service runs thousands of business-critical applications around the world, and we are excited about our recent release of Tanzu Application Service 3.0. This latest version furthers the developer experience with enhancements including shared application routes that enable you to move applications across teams without downtime, step-up app auto-scaling so your applications can scale up faster to handle large traffic requests, integrated Windows authentication support in the .NET Core build pack, giving you the ability to modernize more of your application portfolio, and much more. In exciting news, you can now use the much-loved CF push experience to deploy your app to Kubernetes using the Application Service Adapter for VMware Tanzu Application Platform. The Spring ecosystem has set a really high bar for the expectation that by just dropping in this library, it just works. That's how the golden path and an app platform should support you and enable a great developer experience on any cloud. Join us for a session that demos what it means to have a ticketless golden path and what that experience looks like with Tanzu Application Platform. And let us know if you'd like to get hands-on with the Tanzu Application Platform as well. Thanks, everybody.
Say no to tickets. I think we can all agree with that. If you haven't checked out what we're doing in the Tanzu application platform yet, I'm telling you, you need to take a look. Well, what we wanted to show you today was how the Spring community is doing. The release of GraalVM with Spring for more efficient native compilation and execution, and 3 different golden paths to production for Spring on Azure Spring Apps, Enterprise, on Cloud Foundry with VMware Tanzu Application Service, and on Kubernetes with Tanzu Application Platform. Of course, you can still run Spring wherever you want. It's all about getting you coding and getting your cloud-native apps to production wherever they live.
Coming up right after this and continuing for the next 2 days, we've got some great talks that dive deeper into the technologies that we touched on during today's main stage. After all of that, we're going to keep the goodness going and the knowledge flowing with sessions live streamed each week until our in-person SpringOne event at VMware Explore on August 21st through the 24th in Las Vegas. Don't forget to join our Discord throughout the event where you can chat with speakers, ask our experts questions, and connect with the community. You can also keep the conversation going by using our hashtag SpringOne on social media. This next year is going to be exciting for our ever-growing community. There's something like 33 million developers in the world, and last I checked, there are more than 10 million Java developers too. Although, most of them are using Spring and Spring Boot, which sounds great, except that the world just passed the 8 billion person threshold, which means that there are, most of 7 billion people still not building apps with Spring Boot. So I guess the mission continues. Yeah. You're going to see more and more cloud-native applications. Over 75% of organizations are planning to significantly grow their Kubernetes use. It's growing and mixing together like a great gumbo.
Let's close out with some quick housekeeping. We received so many great talk submissions for SpringOne that we couldn't fit them all into 3 days of SpringOne Essentials. So we're launching a new series on Tanzu.tv called The Golden Path to SpringOne. These talks will be live streamed weekly on Tuesdays and Thursdays at 12 o'clock Eastern Time starting on January 31st. You can find those on Tanzu.tv, and the replays will be hosted on the SpringOne and VMware Tanzu YouTube channels. Also, the recordings for this week's event will be available on YouTube in early February. And with that, thanks so much for attending.